Good morning. हाँ सॉल्व करिए लास्ट टू करिए एटा स्टार्ट कर दो तो हम स्टार्ट करें क्रिस्टलोग्राफी तो सिंपल कहया गले क्रिस्टलोग्राफी इज स्टडी ऑफ क्रिस्टल so what is a crystal so first thing crystals are solid polyhedral bodies bounded by well developed smooth surfaces in which atoms are arranged in a definite pattern so first thing was crystal it should be a solid body any liquid or other form cannot be considered as a crystal and polyhedral it should have many faces and all the faces should have well developed तुम्हें normally कौन-सी की crystal देखो जब like this कि पत्थर-पत्थर जा देखो so different shape they cannot be considered as a crystal because they doesn't have any face. So for a crystal they should have many faces and the faces should well develop. So जाको well develop ही दरकार. And within the crystal the atoms or ions they should arrange in a definite pattern. So the pattern should be repetitive. Pattern को definite pattern ही दरकार है और repetitive ही दरकार. And whose surface irregularity reflects its internal symmetry. That means from the external form we can assume the internal atomic arrangement or internal structure. So this is called as a crystal. बुझ So these are solid polyhedral bodies. Those are bounded by well developed and smooth surfaces in which atoms are arranged in a definite pattern. जैसे कि तुम्हारा बाहर एक्सटर्नल फॉर्म जहाँ आसिबो that will be reflect the internal atomic arrangement. Suppose like this is a crystal. So crystals it should have a definite pattern. So here in this case you can consider this is a small cube and it will repeat itself to form a complete crystal. So ନିଜକୁ repeat କରିବ ଗୋଟେ complete crystal formation କରିବା ପାଇଁ ଯଦି ତୁମେ consider କର ଯେ କୌଣସି ଘରର କାନ୍ଥ ବି ଦେଖ କି ଇଟା ତର ରିପିଟ୍ ହବ ଗୋଟେ ରିପିଟ୍ କରିକି ତମେ ଗୋଟେ କମ୍ପ୍ଲିଟ୍ କାନ୍ଥ ତିଆରି କରୁଛ ସୋ ଯୋଉଟା ଇଟା ତାର ବିଲ୍ଡିଂ ୟୁନିଟ୍ ଗୋଟେ କାନ୍ଥର ସେମିତି କ୍ରିଷ୍ଟାଲର ବିଲ୍ଡିଂ ୟୁନିଟ୍ କୁ ଆମେ କହନ୍ତି यूनिट cell. This small one is your unit cell, so it will repeat in a particular or definite pattern to form a complete crystal. And the external form it will indicate about the internal atomic arrangement or internal structure. बुझिपाला what are the different parts of the crystal? So you can consider face, edge, corner, and intermedial angle. So face is the adjacent side of the crystal. These are faces, and where two non-parallel faces meet, they will form an edge, and where three or more faces will meet, that is your corner. So at the face, we can measure the angle between face because the angle between face will be different. Suppose it will like this, or it can be like this. It can be like this. So angle between face will be different. So the angle between two adjacent faces is called as your interfacial angle. So angle between two adjacent faces it is called as your interfacial angle and it is measured by instrument called goniometer. So the instrument हम use करते to measure interfacial angle. So this is the instrument. ये जो part देखो so this part is movable. ये part एमती कौन movable ही परिबो. तो এটা গোটে crystal face সହିତ coincide করে রাখিবো and this one with the another face. So then it will measure the angle. Then ଯୋଉଟା ରଖିବେ ସେ ଅନୁସାରେ ଏଇ ଯୋଉ ମୁଭେବଲ୍ ଗୋଟେ ଡିଗ୍ରୀ କୁ ପଏଣ୍ଟ କରିବ, that is the interfacial angle between the faces. ବୁଝିପାରୁଛ? So this is your contact goniometer. So adjacent side of the crystal, it is face, where two adjacent faces meet, it will be your edge, and where three or more faces meet, that will be your corner. Then come to crystallographic axis. So crystallographic axis, this can be defined by three or four imaginary axes, you can say. So for the dimension of the crystal, we use three or four imaginary axes. Mostly case we will use three. Only in one case we'll use four imaginary crystallography axes. So the three axes is denoted as A, B, C. We got a diagram for other lectures. So it is denoted as A, B, and C. So A axis it runs from front to back. A axis that runs from front to back. The front side of the crystal to the back side of the crystal. Then B axis from right side to the left side, and C axis from top side to bottom side. So this is your front, back, right, left, top, bottom. So front side always considered as positive and the back side is negative. Similarly, right side is positive, left side is negative, and top side is positive, bottom side is negative. So front to back, right to left, top to bottom. This is the orientation. Any crystal you have to represent the crystallographic axis. With crystal have crystallographic axis represent କରିବାକୁ ଚାହୁଁଛୁ, then we can represent three imaginary crystallography axes. One running from front to back, another right from left, and another is top to bottom. So they are denoted as A, B, and C. See, this is your three imaginary axes. So the three imaginary axes, they may be mutually perpendicular to each other, or there may be other angles. So the angle are denoted as alpha, beta, and gamma. So alpha is angle between positive B and positive C, angle between positive B direction and positive C direction. Beta is the angle between positive A and positive C direction, and gamma is the angle between positive A and positive B. You can see here. So this is your positive B and positive C. This angle is called as your alpha. Positive C and positive A, this angle called your beta, and positive A and positive B, this angle called as your gamma. So there are three angles: alpha, beta, gamma. So different crystal, you'll find different relationship between alpha, beta, gamma, and also different relationship between A, B, and C. So these three axis dimension or three axial dimension, it is the basis for the classification of crystal system. तो ए बेसिस से तुम्हारा क्रिस्टल सिस्टम क्लासिफाई कराई। So in any case, if A is equal to B is equal to C, then we use A1, A2, A3 instead of ABC. ABC ଆମେ ୟୁଜ୍ କରିବାନି ଯଦି ସବୁ ସମାନ axis ଥିବେ. So instead of we use A1, A2 and A3. In one case, that is with the hexagonal crystal system, we use four crystallography axes. तो चारिटा crystallography axes use करନ୍ତି. तो कौन है A1, A2, A3. So it A1 तो मुझे front to back जाऊँगी, but A3 होगी back to front आऊँगी. And A2 will be similar right to left, and C will be similar top to bottom. Basically A3 गोटे add होगा, तो देखिए back to front हम consider करियो. A1 तो मैं कहिबो runs from left side to the front to the right side of the back. A3 that runs from left side of the back to the right side of the front. So in this case, always A1 is equal to A2 is equal to A3, and C will be unequal. So here you cannot represent alpha, beta, gamma. Alpha, beta, gamma it is not represented here. So the angle between A1 and A2 it is 120 degree. So any angle between the positive ends of A1, A2 and A3 will be 120 degree. বুঝবে না? तो crystallographic notation system. जब फेस को सब सिंबलाइज करते डिफरेंट तरह से पड़े जो वन नॉट नॉट वन वन नॉट सो केमिति हम सिंबलाइज करते फेस को सेगरा देखियो जो क्रिस्टलोग्राफिक फेस अछि they are intersected by the crystallographic axis. So crystallographic axis ର intersection with the face is called as your crystal intercept. छोटा एग्जांपल हम दवा दरा तो टू रे देखो दिस इज ए crystal. So this is A axis and B axis. So this is B axis, this is A axis. So as you see, suppose this is a face A, B, C, D. So AB face, it is intersected by A axis. Suppose BC face, it is intersected by B axis. So a crystallographic axis, when intersect a plane or face, the distance from the center of the crystal to the intersection point is your intercept. It will become this much is your intercept. बुझिपारछ एटा काम कबे इंटरसेप्ट सो गोटे क्रिस्टल रो सेंटर रो गोटे फेस को से केते डिस्टेंस रे इंटरसेक्ट करछि ताको हम कहंती इंटरसेप्ट. So the crystal center will be around like this. A point रे कोठा हो A2 तुमे कोन से एक्सिस इंटरसेक्ट इंसर्ट करिवो से क्रिस्टल फेस को from the center at some distance intersect करिवो. So that is the intercept. Intercept माने बुझि पारछो. So it is simple the distance from the center of the crystal to the intersection of crystallography axis with a plane or with a face. So we will take this crystal. First हम 2D रे लिख देबा तापरे बुझ पारी. Suppose we want to find what is the intercept of AB face. So intercept of AB face, if you want to find out what is the intercept of AB face, first you have to see crystallographic axis, that is A and B, they are intersecting AB plane or AB face at what distance from the center. Center ru kete distance re AB face ku A axis or B axis intersect korchhenti, that is the intercept. Because we are considering here in 2D case, so that's why we will consider only two axes. 3D we have to consider three axes, that is A, B and C. So AB face को कितने distance से intersect करते from the center. So intercept of AB face. So first, our A axis intersecting AB face. A axis intersecting AB face at this much distance. Let's say it is 2 centimeters. So the intercept of A axis on AB face is 2 centimeters. Then we'll see what will be the intercept of B axis on AB face. Intercept of B axis on AB face. So AB face is parallel to B axis. So that means AB face and B axis will only meet at infinite, because two parallel lines will meet at infinite. So B axis will intersect the AB face at infinite. So the intercept of B axis on AB face, it will be infinite. So intercept of A axis is 2 centimeter, intercept of B axis is infinite. So the intercept of AB face, it will written as in a sequence of A and B. So it will be 2 infinite. It will be 2 infinite. Understood? If this is your 2 centimeter, then what will be the intercept of BC face? So what will be the intercept of BC face? What will be the intercept of BC face?
तो 4 cm हबो कि
4 cm को भाई
सर BC फेस जो B एक्सिस इंटरसेप्ट করছে সেইটা 2 cm ଅଛି and B axis पे ଯାଇକି A axis को भी इंटरसेप्ट କରୁଛି
BC face, ठीक है. हम देखियो कि BC फेस को A एक्सिस और B एक्सिस सेंटर रो केते डिस्टेंस से इंटरसेक्ट करछो.
आज्ञा सर
तो BC फेस को B एक्सिस टाइम इंटरसेक्ट करते सेंटर रो एते डिस्टेंस रे.
आज्ञा सर
अब A एक्सिस BC फेस को इंटरसेक्ट करछो ना करनी. तो दिरा
Not
को
the
parallel
correct.
अछि दिरा
Again.
parallel अछि ना नहीं दिरा
Yes.
parallel line कोठी meet करिवे
कोठी से meet करिवेनी.
infinite रे meet करिवे two parallel lines should meet at infinite को आए हैला so दिटा parallel line तो infinite रे meet करिवे हमरे b रो intercept BC face रे intercept of a axis केता हो
Infinite.
infinite so हम sequence रे लिखिबा a और b तो first है जो infinite तापर जो 2
2.
CD face रे
Yes,
बाहर
sir.
करी को मते CD face रो is also 2 cm
The CD.
हां CD
The 2 infinite.
तो हम এটা 2 न लिखिए कि हमें जो a साइड टा पॉजिटिव ले जाए a साइड टा नेगेटिव ले जाए तो हमें -2 बाहर
Minus 2
एक्चुअली
infinite. Okay.
तो 2 बार इनफिनिट तो मैं लिखियो का लिखो 2 बार
2 by
इनफिनिट
infinite.
द अपोजिट साइड इज नेगेटिव तो बुझी पाइल कि
Again, sir.
तब देखले जदि मोर क्रिस्टलोग्राफिक एक्सिस फेस को सेंटर जेति डिस्टेंस इंटरसेक्ट करूची ताको हम कहती क्रिस्टल इंटरसेप्ट सो हम आ गोटे कंडीशन देखिबा अभी सब जे एवढा क्रिस्टल अछि सपोज हम नबा ए फेस नबा दिस इज ए बी फेस सो approximately what will be the intercept of AB face? So this is your B axis, এটা হলো কত বড়? B axis, এটা হলো A axis. So A axis, what will be the intercept of A axis of AB face? কেটা হবে? A axis of AB face এর intercept কেটা হবে? তুমি কहो যে A axis AB face को intercept କରିବ ନା ନାହିଁ?
Sir, ଗୋଟେ point ଯାଇକି intercept କରିବ. କାହିଁକି parallel ତ ନାହିଁ.
तो जोठी एमती कंडीशन देखिबा so you have to imaginarily extend that face. ଆମେ କଣ करे ए face को imaginarily extend करो ହେଲା then it will intersect that face তারপর সে face को कौन करियो इंटरसेक्ट करियो इफ यू विल इमेजिनरी एक्सटेंड दैट फेस तो आइदर गोटे फेस जदि तुमको देखुछ कि इंक्लाइंड अछि दैट मींस कि दे विल इंटरसेक्ट विथ ईच अदर तो फ्रॉम सेंटर से जो इंटरसेक्शन पॉइंट होगा दैट इंटरसेक्शन पॉइंट विल बी द इंटरसेप्ट ऑफ ए एक्सिस ऑन ए बी फेस एंड दिस विल बी द इट ये इंटरसेक्ट कर जाउछि दिस विल बी द इंटरसेप्ट ऑफ बी एक्सिस ऑन ए बी फेस so these two value they are unequal so that's why we use hk for the c-axis ho then L use kara. So these are unequal number. So it may be 5 centimeter, 6 centimeter, it may be more than 6 centimeter, 7 centimeter. So instead of using that, we use HK. So এটা বুঝি পাইল?
yes sir.
So this is a crystal intercept. So where the distance along a crystallographic axis to its intersection with the crystal face from the center. So crystal intercept, it is very difficult to represent because quick crystal intercept रे कौन था है तुम्हारा कि unequal बा fraction और whole number different different number आसवे जोटा कि difficult to represent. तो ସେଥିପାଇଁ तार आउ दीटा way रे बा दीटा way तक represent करा जाए गोटे जो Bayes parameter आ गोटे Miller indices. So Bayes parameter कौन and Miller indices कौन देखबे? So suppose this is a crystal. So crystals are consist of repetitive unit. Repetitive unit being theory is. Suppose धर आम कहले कि एटा गोटे कांथ अछि. तो कांथरे कौन एमती इटा थिबो. तो कहला कि 2 3 4टा इटा अछि. ओके. सब भाबे जे सब समान साइज अछंती. तो गोटे रे लेंथ होछि केते सेंटीमीटर. which 1 सेंटीमीटर. ताल टोटल कांथरे लेंथ केते हबो. तो गोटे रे लेंथ 1 सेंटीमीटर टोटल कांथरे लेंथ केते हला.
Sir 4 cm.
4 सेंटीमीटर. So सेवरा crystals are repetitive unit. गोटे यूनिट रो जो बिल्डिंग यूनिट रो लेंथ जदि हमें जानिबा ताले से केते थर रिपीट हेजी गोटे क्रिस्टल फेस को दैट विल गिव द इंटरसेप्ट. सपोज हम एठी पर नीचंती ये 1 सेंटीमीटर ये 1 सेंटीमीटर. ठीक है. So it will intersect suppose this face, CD face. So what will be the A axis intercept on CD face? केता हबो.
So 3 cm plus end to से point पर्यंत जेते लेंथ हबो.
CD खाली 8 हबो ना. BC पे 8 हबो.
Sir 3
CD
cm sir.
face 3 cm 1 2 3. So 3 cm habo. Then what will be the V axis intercept on CD face? It will be infinite because B face it is parallel to CD. B face is parallel to CD. And this crystal has a unit length of 1 1. Unit length of 1 1 1 we will take, and we assume that the C axis is also parallel to CD face. So the symbol will be 3 infinite infinite for crystal intercept, and the unit cell is this much 1 1 1. So crystal intercept by unit length. Crystal intercept by unit length is a Bayes parameter. Crystal intercept by unit length is a Bayes parameter. And Miller indices your unit length by crystal intercept. Unit length by crystal intercept. It is the reciprocal of Bayes parameter, or Miller indices is the reciprocal of intercept. Directly you can say the reciprocal of intercept. So the crystal intercept is 3 infinite infinite and the unit length is 1 1 1. So for Bayes parameter we can write down 3 by infinite, sorry, 3 by 1, infinite by 1, infinite by 1. So it will remain 3 infinite infinite. But if you consider Miller indices. So it will be unit length by intercept. So it will be 1 by 3, 1 by infinite, 1 by infinite. So we can multiply 3, 3 into 1 by 3. So 1 by infinity will be 0. So 3 into 0, 0, then 0. So it will be 1, 0, 0. It is represented as 1, not. Understood? So the symbol of CD phase, what we represent, that is 1, not. So Miller indices is how phase को represent करा जाए. So any phase that parallel to any crystallography axis that are parallel to a phase, the intercept will be 0, and if it is intersecting at some distance, then accordingly you will take the number. Which Bella?
Yes, sir.
So you can take the reciprocal of intercept. The intercepted reciprocal number, it will be the reciprocal of intercept will be Miller indices. Suppose these are different your intercept. ठीक है? So ମୁଁ ଗୋଟେ କରିଦଉଛି. So 1, 2, 2. Suppose these are intercept. So the 1, 2, 2 intercept ହେଲା, the Miller indices will be 1 by 1, 1 by 2, 1 by 2. Then you have to take the LCM. It LCM ତମେ ନବ. So the 1, 2, 2 the LCM will be 2. 2 into 1 by 1, then LCM ଟା ସବୁଥିରେ multiply କରିବ. 2 into 1 by 2, then 2 into 1 by 2. So it will be 2, 1, 1. So the Miller indices will be 2, 1, 1 for intercept 1, 2, 2. ବୁଝିପାରିଲ? ତମେ ଏବେ calculate କର B, C, D, E 3 4 calculate କରି notation system. So in case of hexagonal system, actually there are 4 axes. So hexagonal system में जो 4 axes है, the 4 axes are denoted as H, K, I, L. In case of they are intersecting at unequal angle, or in Miller indices we use H, K, L. H for A axis, K for you can say B axis. This is for your A3 axis, and this is for C axis, L for C axis. So usually in other cases we use HKL, but in case of hexagonal system, that is where there is 4 axes, we use HKIL. So always there is a relationship between H, K and I is equal to 0. Always remember H plus K is equal to minus I. H plus K is equal to minus I. Understood? Then comes to axial ratio. So what is axial ratio? Axial ratio, it is defined as the relative length of crystallography axis with, you can say, take the ratio of all axes with B axis. Simple. So suppose there are 3 crystallography axes A, B, C. You just take a ratio of B axis with all axes. This will be the axial ratio. So A by B is to B by B is to C by B. This is your axial ratio. So for different crystal system, the value will be different because in case of suppose the isometric crystal system, all axes are of equal length. If A1 is equal to A2 is equal to A3, then the ratio will be A1 by A2, A2 by A2, A3 by A2. So the value will be 1. Similarly for tetragonal system, it will be 1 is to 1 is to C by B because tetragonal system also has A1 equal to A2 not equal to C, and also hexagonal system 1 is to 1 is to 1 is to C by A because all the horizontal axes A1, A2, A3 are equal length. And for triclinic and monoclinic system and orthorhombic system, they are unequal axes. A is not equal to B, not equal to C. So the ratio will be A by B, B by B, C by B. So A by B will be like this, C by B will be 1, and C by B, B by B will be 1, and C by B will be like this. So the ratio will be like this. So this is called as the axial ratio. Understood? Then come to crystal form. What is a crystal form? So the different crystal they consist of different phases. So on the basis of different phases and their arrangement, there are different types of crystal form. First one is your simple form. Simple form is the crystal consists of all similar phases. Like a cube, you can say here it is consists of all similar phases. All the crystals are not consist of all similar phases. सब क्रिस्टल रे सब जगह फेस सब समान न थाए. एट जो हम देखते कि these four phases are one type and these two phases are other type. This is also can see these four faces are one type and the top and bottom faces are different. But a simple form, a crystal consists of all similar faces. It's a cube, octahedron. This is the example. This is a cube. The managed combination form it consists of two or more simple form. Suppose this is your example. One, two, three, four. These are one type of face, and top and bottom are other type of face. So it is a combination of two simple forms. These four will consider as one simple form, and the top and bottom will consider as one simple form. So it is a combination of two simple form. Then comes to your open form and closed form. So what is an open form? If crystal doesn't have sufficient number of faces. If I considering a simple form, if it doesn't have any sufficient number of faces to enclose the space, it is called an open form. Suppose here in this case, it is a combination form. It consists of these four vertical faces and top and bottom faces. So four vertical faces are one form, and these two are two another form. So if you only consider these four vertical faces, it will not enclose the space. It will not enclose the space. This will remain open. So no face. Suppose consider this is also no face. तो जगह फांका रहेगा ये चारटा face रहेगा. So this will be four faces and there is no face here. So it will be considered as an open form because it doesn't have sufficient number of faces to enclose a space. So it is फांका रहुଛି ସେଥିପାଇଁ it is considered as an open form. To only take these two faces, they will also not enclose the space. So those are called as open form. But if you see that this cube, it consists of sufficient number of faces to enclose a space. So it will be a closed form. ବୁଝିପାରୁଛ? ତ ଗୋଟେ ସିମ୍ପଲ ଫର୍ମ ରେ ସେତିକି ନମ୍ବର ଅଫ ଫେସେସ୍ ଥିବା ଦରକାର ଯୋଉଟା କି ସେ ଗୋଟେ ସ୍ପେସ୍ କୁ କ୍ଲୋଜ କରିବ. If it doesn't have that number of faces, then it is called as your open palm. देखिए ଆଉ ଥରେ ଯଦି ଡାଉଟ୍ ହଉଛି ପଚାର ନହେଲେ ଆଗକୁ ଯିବା।
सर सिंपल फॉर्म और क्लोज फॉर्म में डिफरेंस कौन?
Simple form, it can be open or can be closed. Okay. Suppose there are these four vertical face, they are simple form. These upper and lower face, they are simple form. But only if you consider this simple form, it is an open one. This is also a simple form, but it is a closed one. So simple form, it is simple, consists of similar faces. But if that much similar faces, if they will enclose the space, then it will called as closed form. If there are not sufficient face, will be open form.
ओके सर.
So these are different example of open forms and closed form. So ଏଟା ପୁରା ମନେ ରଖିବାକୁ ପଡିବ। So pedion it consists of a single face. Pedion consists of single face. Single face नहीं crystal ହେଇପାରିବ କି?
नो सर.
ତାହେଲେ କ'ଣ ହବ single face କେମିତି consider କରାଯାଏ ଏଠି? कि suppose कि consider କର कि ଗୋଟେ crystal face ଅଛି, it consists of all dissimilar faces. ସବୁ ଯାକ dissimilar faces ଅଛି, then each one can be a pedion. ଏମିତି ଧର କହିବା ଆମେ ଏଇଭଳିଆ faces. So each face କ'ଣ is dissimilar with each other.
आज्ञा सर.
So each can be considered as a pedion. So it cannot exist alone. So it always exists in a combination. Similarly, pinacoid. Pinacoid consists of two parallel faces. It has two faces and consists of two parallel faces. So you can see, suppose this is one face and this is other face, the top bottom face. They are parallel to each other, and this face are similar. So according to the condition, if two faces are parallel to each other, then it is called as your pinacoid. So pinacoid is consists of two faces parallel to each other. Then comes to prism. So prism consists of 3, 4, 6, 8 or 12 number of faces. Prism consists of 3, 4, 6, 8 or 12 number of faces. All faces are parallel to a common line. So this is the axis. So this axis is parallel to all the vertical faces here. This axis is सब vertical face को parallel আছে. So that means these four faces they can be considered as a prism. So prism रे एमती गोटे in the prism is a form where all the faces are parallel to a common line. तो सब जगह फेस गुड़ा गोटे common line को parallel हवा दरकार. बुझिपाइल? वेट कर जो पिलाटा कटि जाई आस So prism it consists of maybe 3, 4, 6, 8, or 12 pieces. Then comes to pyramid. Pyramid is also consist of 3, 4, 6, 8. So unlike prism, to take prism रे कौन थला सब faces पूरा they must parallel to a common line. They must parallel to a common line. But in case of pyramid, all the faces must intersect to a common axis. सब जगह face कौन करें? ଗୋଟେ common axis को intersect କରିବା निहाती दरकार. That is called pyramid. Pyramid is an open form. Prism in an open form. Always this part on this side is always open. There is no face here. Then comes to dome and spheroid. Both consist of two faces, two non-parallel faces. So pinacoid consists of two faces. Dome and spheroid is also consist of two faces. But in case of pinacoid, those are parallel faces. Pinacoid कौन था? Parallel faces थे. But in case of dome and spheroid, these are non-parallel faces. Like this. The dome and sphenoid both consist of two faces and both are non-parallel faces. But in case of dome the mirror plane is dome is characterized by a mirror plane and sphenoid is characterized by a twofold rotational axis. That is the difference between them. Dome रे mirror plane था, sphenoid रे twofold axis था. Then there are also other forms. There is your scalenohedrons, trapezohedron, disphenoid, dipyramid. So just remember the number of faces and shape of faces. So scalenohedron होची 8 or 12 faces, 8 face heber नले 12 face heber and consist of scalene triangle shaped faces. ସେଗୁରା ଖାଲି ସେଗୁରା ମନେ ରଖିବ କି କେତେଟା face ଅଛି. So the disparate face it has four faces. Disparate has four faces. It is a closed form. That is the minimum number of faces for a closed form. That is four faces. Charita face रे तुम्हारा space enclosed हो. So there is a minimum number of faces that produce a closed form. Then comes to general form, special form, and restricted form. So these are on the basis of indices. If the indices are unrestricted in magnitude, that means the indices can be variable. So suppose if we write down uh, a symbol of Q, so you can write down one not one not one. Anything, any can be a symbol of Q. So that means it has the places H, K, and L places are variable. So H places can be varied from 1 to 0, K places also 1 to 0, and L places also 1 to 0. So that's why if it is variable, then the form is called as your general form. For example, is your Q. So it is variable. So in special form, only one possible set of value exists for indices HKL. That means ki suppose if you take octahedron, it will be 111. Any faces, the symbol will be 111. That means ki it can be 1 bar 1, or you can take a bar sign, but the value will be always 1. It will not change. So there are certain form where the value will restricted. Unlike cube তুমি যেগুলা গোটে জায়গায় 1 or 0 यूज कर पारथिला একটা তোমার octahedron রে always all faces will be 1. In restricted form is partly general, partly special. So এটা completely special হবনি, completely general হবনি. Partly special, partly general মানে partly আর fixed থাকে, partly variable থাকে. যদি ଆମେ consider କରିବା ସେ prism କଥା ଦେଖ prism ରେ କଣ ଥାଏ कि ସବୁବେଳେ ଗୋଟେ ସବୁ फेस को parallel, तो जदि गोटे एक्सिस सब फेस को parallel तो से एक्सिस ର इंटरसेप्ट ସବୁବେଳେ 0 हो, तो एच के नॉट हो। तो ये दुईटा पार्ट तुम वेरी करि परियो, बट दिस पार्ट इज ऑलवेज फिक्स। 3 4 0 लेखो 1 2 0 जहाँ ले भी कौन हो। So this part is fixed and this part is variable. So this is called as your restricted form. बुझिपाल? देखो डाउट हो आउथरे पचार। बुझिपाल बिबू? नेक्स्ट होची दिस टाइप ऑफ फॉर्म, एटा हम देखिया आफ्टर कंप्लीटिंग सिमेट्री। सिमेट्री ऑपरेशन पर हम इस टाइप ऑफ फॉर्म को डिस्कस करिबा बिकॉज़ इट इज रिलेटेड टू सिमेट्री फॉर्म्स।